Welcome all of you to the session. For those who have not used these things, machine learning for kids, and there are other such platforms. If you go there, the basic approach is that you train a model. There is a model, there is an invisible model, of course, and you feed the data to the model and you train the model. For example, you train the model how to distinguish between the images of a flower and a fruit, for example. So you upload certain images of fruits and some images of flowers, let's say 10, 20 images of each. And once you submit those images into it, and when you click on the train button, the model gets started training. It extracts the features of the images and trains itself. And once the model is ready, that model is available as a link to you. You can use that link to fetch that model into any Scratch application or in an MIT App Inventor application or in your Python programs. So this way, whatever model you have trained online, it is available through a link or through an extension, and that can be used on your local machine using a Scratch interface or MIT App Inventor, which way. So this is actually the flow of the machine learning tools. So this is a Google online tool, teachable machine.withgoogle.com. There is another platform which is called Machine Learning for Kids. Machine Learning for Kids. You can simply Google them. You can either Google teachable machine, or you can either Google Machine Learning for Kids. So when you go for these projects, the projects which you have already created are available over here. You can, of course, create an account and log in into that. These are the free tools. So you just have to create an account and log in. So this is my account where I have created 3 projects already. And for more projects, I can go for adding a new project. So I can go for adding a new project. So if you want to create something, first of all, you have to be very clear what exactly are you going to work with. I'll click on this add a new project button. I hope that is the screen is clearly visible to you. At the top, somewhere on the right hand side, you will find add a new project. As I click on this, I'm talking about machine learning for kids platform. So when you click on add a new project, it will ask you about the project name. So you can give a relevant name here. Here I'm just giving a generic name. What kind of project you want to create? So here it is going to let you create a project which recognizes text or images or numbers or even your voice, and predicting the numbers is the feature coming up. So if I go to images here to recognize images, so I'm going to create a classification model which will be taking images and it will be training itself to recognize images. And this is important. Where are you going to store this model? So you always choose from here in the cloud, because if you choose web browser, by the time you make more models, your web browser will have that load and your machine will have to run it. So you better keep it in cloud. So you select here in the cloud. I click on create button. So I just showed you how you can create the project. Once you create the project, what happens is this screen comes. And in this screen, you will first of all train your model. So for training the model, you click on train button. Now in train button, what happens is in this training screen, you need to create collections of images like this. These are called labels. So what happens is, if I want the model to recognize flowers and fruits, so I'll click on add new label. So I'm clicking on add new label here, and I'll give a relevant label name, for example, cars. I click on add here, and you see a cars label has been created. All I have to do is I have to have certain images of cars available with me, and I will upload these images over here. So either I can go for webcam, I can switch on the webcam of my computer and click the car images from the webcam. I can draw also, which is a tedious task. The easiest way is that you get the images from online and you put them here. So how do you do that? Let me show you. There is one website. You should know which free websites provide certain images. One of them is Pixabay. So I go to pixabay.com. This website has no copyright issues, and you can simply take free images and use them. So I click in here and I click on, I type cars over here, and so many images of cars are available here. All I have to do is I bring this window out like this and keep it aside so that my other window is visible over here. These are the cars images, and one by one, I drag the images from here and put them in this bucket, in this label bucket. At least take out some good number of cars, at least 8-10 images would be good. So you take random images of cars like this. So once you see that enough images are over here like this, you can click on back to project. You see back to project is on the left hand side, this link. And or you can create more labels. If you want that flower, fruits, cars, and motorbikes also have to be there, you can click on add new label and you can create another collection of images of bikes. So this way, you put the images over here, you go back to the project, and then you say learn and test. The next step is learn and test. Now here, once the model is trained, so it will take some time to get itself trained. And here you can test it by the help of webcam or test by the help of drawing, or you can test with a URL. I have shown you the process here that when you go to the project, any which project, suppose this voice command project is there. So for training, what you have to do? For training, you have to create various labels over here like this. Like this is one of my sound projects where I have added 3 labels. Background noise is by default. Whenever you are doing a sound project, it will first of all record 8 to 10 samples of background noise so that it is able to understand what noise is. And then you can create, in each bucket, you can create click on add new label. I have created 2 labels by clicking on this button, start label and stop label. And then I can click on add example. Here, if I click on this button, it will take the recording from my microphone and will save that file over here. So here I click on this microphone, start. I have recorded the word start and I have added it here. So this way, you can add your voice samples over here. When you click on add example in any of the labels, it will pop up the voice recorder for recording the voice. So similarly, when you go for, so this is a sound project. Instead of sound, if you are going to have images project, you just have to drag drop the images into the labels. The process is same. It's only that the medium is different. So voice commands are, once they are, the voice commands are done, you can click on learn and test. You can click on train. You have created the labels. If you want to add more voices, you can add more voices over here. And once it is done, you go back to the project page. You click on learn and test. And here, when you click on learn and test, since it is a voice project, it will like to listen what you say, and it will try to interpret what you have said correctly or not. So if I'm clicking on start listening, start. So see, it is saying 77% on start. Stop. It has taken stop. Now I'm saying good night. Good night is the one of the recording in start label was good night. Switch on the lights. 91%. Switch off. 93% for switch off. So start and stop label, in these labels, I have actually given the voice commands to switch off the lights or switch on the lights. So I've given various commands and under start label, and I've given various commands under stop label. So my model is trained on these voice labels. Once the training is done, I go back to the project and I click on make. It has compiled it and I can open Scratch 3 over here. Again, click on open in Scratch 3. So here it is opened up like this, the Scratch interface. Now I have already created one sample over here. So here you can use teachable machine, or if you open Scratch 3 over here, I show you from starting. If you notice here, voice commands, the same project name, the project name which you had used to train the model here in machine learning platform. When you go to the projects, what is the name of the project? Voice commands. Voice commands is the project name. And when you go to the Scratch interface, it is showing the voice commands extension added over here. So the model which you have created on machine learning, it is available as an extension over here by the same name. Here it is voice commands. So when I click on voice commands, it will show me these commands already created in the form of blocks. So here it is saying when I hear start, when I hear stop, and accordingly it will respond. So what I have done is I have taken a sprite, cake sprite. This cake sprite has two costumes. One costume is the candles are switched off and the other costume is the candles are switched on. So I have trained my model to take the voice command and switch on and switch off the devices. So what I will do, I have taken a cake which has switch on and switch off candles. I go to the code. When I'm clicking on green flag button, that means when I'm starting the animation, I have taken this block, start listening. So when I click on the green flag, the model will start listening to the microphone, and start listening block is over here. I have taken this block from here. So start listening will happen and the microphone will be captured by the model. And then I have taken when I hear start. When I hear start, you remember the labels which we created in voice command model? In voice command model, we created two labels, start label and stop label. And in start label, it was all the commands to switch on the lights, and stop has all the commands to switch off the lights. So here, let me check out. If I say start, did you see? Switch off. So this is how the model is working. I have shown you the process. So here you train the model on machine learning for kids platform, and in Scratch interface, you use that model by the same name and these blocks to create your application. So this way, this is the flow of the machine learning for kids platform. You can either create images or you can either create voice commands, whichever way you like. So teachers, I showed you one simple process where you can involve the kids into this kind of machine learning model training approach in lab or in classroom. You can demonstrate and then you can leave them in lab to do themselves. The similar kind of platform is Teachable Machine. So here also you can create image projects or audio projects, or you can create a project where you can create poses, for example, doing yoga exercises and all those things. So pose project can also be created over here. So whichever project you want to create, you can click on that. For example, if I want to create an audio project or let's say image project. So in image project, if I go here, it will be showing me the classes. I can create a class, for example, car, or I can create another class over here, bike. Same approach is there. Only the interface is different. And I can click on webcam or I can upload the images from here. The approach is easier over here. From there, you have to drag drop the images from an online source. From here, what you can do, you can upload the images which are already saved on your computer. So you can simply click on upload and you can choose images from your computer and you can upload the images which are already there. Similarly, for audio project, what you will do is it will, first of all, it will take the background noise. So when you click on mic, it is going to record for 20 seconds the background noise. What you do is, it is saying add audio samples at least 20. So 20 minutes for 20 samples, it is a lot of time. what I can do, I can click on this button and I can click on number of seconds I can minimize. I can make it 5 seconds. So here you can reduce the duration, and accordingly, when you click on record 5 seconds, it has recorded the background noise. I click on extract sample, and here are the images created. So this way I can record for another 5 seconds. So this is one thing. Then I want to record my own voice commands. So I click on class 2 and maybe I say begin to start something or turn left, whatever voice command is there. I click on mic. I'm just showing you how it works, how the recording works in this particular teachable machine platform. So again, I ensure that 5 seconds are there. I can go into settings and set the duration. And here I click on record 5 seconds and I say begin. It has recorded my voice. I click on extract sample and I check out the samples. This is useless. This is useless. Let me check this out. Say begin. So this last one was okay. So this way you can record. It is asking for 8 samples. So you, one by one you can record. So I extract the sample here. I click here. Say begin. Start. Start. So this is better. I remove the other ones. So this is the process here, how you record the voice labels for voice commands in your project. One by one, you can do that. If you want to save this project on your computer, you simply go here in the menu and you say download project as file. When you click on download project as file, the entire model is saved on your computer by the extension .tm. So you can use it later on. You can give it away to others also to practice. So this is a better approach here. Teachable machine is better than as compared to machine learning for kids. So this can be saved over here. So I've just shown you the approach of recording the voice. Rest of the process, when all the voices are recorded, you can click on train model button for model training. So let me show you one already created project of mine. I click open project from file. This is bulb on off TM project is there. I open it. I have recorded the background noise, 24 samples, and I have recorded switch on labels, around 9 samples over here. So if I play here, good night. Where are the lights? Switch on, lights on, switch on. So I have different samples recorded here, and for switch off also, just the reverse. Switch off the lights. Switch off the lights. Switch off. Good morning. Switch off. So some samples are over here. And when I click on train model, it will take some time and it will get the model trained. I'm not clicking over here because gathering all the voices and training the model will take a while. Once the training is done, when you click on export model, it will give you a link. That link you have to keep safe. So when you click on export model, the link will be generated for you, and the link will look simply like this, just like any other URL. I have already saved my link over here. See, this is the link. And this can be used, this link can be used anywhere where in any interface where I would like to implement it. So teachable machines, now I show you the approach over here. The link I have already got. I showed you how to go on teachable machines and record the voices, labels, train the model, get the link by export command, and that link you have already available. When you open this Scratch interface, if you go into extensions, it will show you an extension called teachable machine. See here, the teachable machine extension is over here. When you click on this extension, you will get the teachable machine extension blocks over here. So what I have done is use model. Use model block I have used with the green flag click. When I click on the green flag, the model which I have trained on teachable machine, that will be fetched over here. How it will fetch the model? In the use model parameter, I will paste the same link which I have already saved over here. The same link has been pasted over here so that my model gets connected with this program. And rest of the things are simple. This block over here, when model detects switch on, when model detects switch off, these are the labels you remember. And accordingly, what I have done is I have taken two images of bulb. One image is off bulb and one image is on bulb. And these two images have been loaded by upload button over here. If you know Scratch, you know how to upload the images in the costumes, how to upload the images in sprites. So I have uploaded the costumes for the bulbs over here. And now the code is actually switching to the particular costume. Switch costume to bulb on, switch costume to bulb off. And if you see, bulb on costume is this one. Its name is bulb on, and this one has the name bulb off. So code is very straightforward. Just to give you a simple demo, the approach. And to test it, I can click over here. First of all, I click on green flag and we can test it out. Good night. Switch off. So this is how it will work. You can test, you can give it to the kids, you can show the approach, and then they can do the experiments over here. So this way, machine learning platform, machine learning for kids platform and teachable machines are used. You need to understand the flow. The flow of machine learning is you have to have some samples of data ready, because machine learning means teaching the machine with the help of data. That data could be voice, that data could be some image on these platforms, and you can record the voices beforehand also to save your time, and you can download the images and save them beforehand. While using these models, you can upload those images and voice commands so that you save your time on online recording. So this way, uh, when all the things are uploaded, how they are uploaded, to teach for classification, we need to create labels or classes. For example, car label, images of bike, images of aeroplane, or the voice command of certain thing, turning the car. You will be saying go left, left, turn left. These are the commands for turning left, similarly for right, and various voice commands can be added. These are called classes, or you can say labels. And using these labels, the model get itself trained, and then you can test it in any interface. It could be a Scratch interface, it could be MIT app, or it could be a Python program. So it depends how much Python programming you know for that, and how much MIT app inventory you are good at. And Scratch is one of the easiest interface to involve the kids, and less explanation goes into that, so that they focus on the concept of AI rather than learning how MIT inventor works or how Python works. So Scratch takes it straightforward to the AI learning actually. For small kids like class 3, 4, 5, they can be involved in simple hand sensing. There are extensions. In Scratch, if you go to Scratch, I show you one of them online tool, playground.raise. Playground.raise, if you go, I type the URL here, playground.raise, you need to Google it. When you go to playground.raise platform, it will give you the Scratch interface, and you can add the extensions. There are extensions for hand sensing. There are extensions for other graphical things from the webcam. And using those extensions, you can program, you can simple demos for kids. So that is for class 3, 4, 5. You can do that. For class 6, 7, 8, you can involve them in machine learning for kids or teachable machines. This platform, which I have showed you, this is very good for class 6, 7, and 8. You can involve them because it needs a lot of things to be done, so grown-up kids can understand this. And for higher classes, you need to create certain samples to show in the classroom. I'll show you in Python how using simple, I'll show you the use of certain Python libraries. And using those Python libraries, you can create simple demos of natural language processing. One is natural language processing. The other is your computer vision. So I have this Python idle you might be having on your machine. All of you might be having this on your machine. Python idle is opened over here. So I'll first of all learn this. I will run this code so that you see the output and understand what is going on. Then I will tell you how it is working. So I run this program. So my program is actually about image filters. One of the basic requirement of processing the image, that is not artificial intelligence actually, but the basic of AI where image processing we see how images are processed. So from the image, the program is actually detecting the edge of the objects in the image. It is trying to detect the outline or the edge of the objects in the image, or it is applying sharpen effect on the image. It is applying emboss effect on the image, blur effect on the image. So all these filters are being applied on the image. So I select first of all one over here. So you see one was edge detect, and this image of Spider-Man, you can clearly see how the edge is detected. Let me try blur effect. So this is the image blur over here. Or if I say emboss, so this is the emboss effect applied on the image. So depending on the choice, the image is applying a particular, the program is applying a particular filter on the image, and using that filter, the image output is coming up. This is a sharpened image. All the edges are very sharp, you can see. So this way, if I press 0, I exit the program. So now let us see how this program is working. Actually, what happens when we talk about image filters, what happens is image filters are nothing but an image is looked at like an array of numbers. So when you see an image, for us it is an image, for computer it is an array of numbers. Fine. And if that array of numbers is multiplied by another array of numbers, if you multiply it in some way, then it is called image filter, or you can say convolution. This is the convolution process which is applying. A convolution process is happening, and because of that, this effect is coming. So I show you here, one of the image filters is edge filter. You see this here. What we have done is we have imported computer vision library CV2. We have imported NumPy library NP. NP is imported to create the arrays of the numbers. And we have used CV2 to read an image called spidey.jpg. Spidey.jpg is loaded in the memory by the object name img. And again, I have used this img object to resize the image to 300 by 300. When it is displayed, it will be a small image of 300 by 300 square. Next, what I'm doing is I'm creating certain filters. For edge, there is a filter. I create this NumPy library I use, and I create the array method of NumPy library. And I'm creating an array with these 9 numbers. In the first row, there is -1, -1, -1, then -1, 8, -1, again, a series of -1. Now, these numbers are actually for for edge detection. If you apply this filter on the image, the edges are taken out. Now, this array is stored in img filter variable. img filter variable is the array which is going to be applied on the image. And img is the object which contains the original image. Now, these two have to be interacted together. How I'm going to do that? There is a method called filter2d. Filter2d method is applied on the image, and it is the method of CV2, Computer Vision 2 library. So I say CV2.filter2d. No need to remember all these commands and methods. I will be sharing these programs with you in email. So you will get these running programs anyway. So nothing to worry about. You can run those programs on your machine and you can show to the students. Filter2d method is taking certain parameters First of all, it is taking the source of the image, which is the actual image, IMG, SRC is equal to IMG, and D depth is equal to -1. Now, this is something very technical, so let's keep this parameter like this, the depth -1. And it is taking the third parameter as kernel. You know what is kernel? Kernel is actually the smaller array. A smaller array, which I am calling filter, technically it is called kernel. So kernel is applied on the actual image. So first parameter is the actual image, src.img, and the third parameter is the kernel. And what value I have given? IMG filter. Remember, IMG filter was stored. It is the array I created for edge. This -1 in 8 wala. So here, at this moment, the filter is applied. The edges are detected. So when the edges are detected, the new image is returned by this method, by this function. So I store this into a separate variable called filtered image. Filtered image is actually the image which is containing the edge detected image. And I'm simply using IMShow method to display that image. IMShow method is also of CV2. So it is straightforward. What you do is you create a filter by np.array method. You create a filter by the help of filter 2D method of CV2. You apply that filter on the image and you get the filtered image, and then you simply show the filtered image. So this program is simply doing this, and depending on the rest of the program is actually simple logic where I'm displaying the menu. Depending on the choice 1, 2, 3, 4, I am creating a particular filter. On choice 1, I'm creating edge filter. On choice 2, I'm creating sharpen, then emboss, then blur. These 4 filters on choice basis I'm creating. And finally, the selected filter has been applied and the image output is shown. So that's a very simple, straightforward approach where you create a filter in the form of an array. You load the image, you apply that filter with the help of CV2 library, and you see the image, how does it look like. So I'll show you another interesting program where you can control the brightness and contrast of the image together. I run this program with brightness and contrast once again so that you see the output first. This is the original image and this is the brightness applied. I press escape key to come out of the program. Let's go back here. I have imported computer vision 2 library, NumPy over here. NumPy was actually not required in this. NumPy is not required here, only CV2. And I load the image by IMRead. I resize the image to 600 by 600. Original image was displayed to you, the first window, which you saw in the output of the program. Variable A is for contrast and variable B is for brightness. I have taken contrast value as 1 and brightness value as 100. In CV2 library, there is a method called convert scale ABS. Convert scale ABS method takes the image, the original image object IMG over here, alpha for contrast, alpha is equal to A, that is 1 over here. Beta is for brightness, variable B over here. And then you saw, then I displayed the image. Now this filter is applied and new image is created. New image was displayed in the second window. So when I was displaying the second image, it was looking different from the original one. So just to test, you can do this something like this. If I say brightness is equal to 0, and I test the program once again. So both the images are looking the same because there is no brightness applied. And if I say contrast also 0, now both are 0. Did you see what happened? Brightness, contrast, both are gone. So all the pixels are turned black. So this concept of pixel manipulation can be showed to the students, and program is not very difficult. It is a straightforward program. If you explain once, I think class 8, 9, 10 students can get it. So I'm bringing it back over here. Let me say 10 is the contrast and 150 is the brightness. So that's pretty higher value. You can imagine what will happen. See this? Too much of it. So you can experiment with these values just to show you the concept of brightness and contrast and convert scale ABS method of computer vision library. So you can bring in these programs in classroom here and there, and you can show these things to the students. Now let us move into something called natural language processing. So you might have seen in class 8th, 9th or 10th curriculum somewhere, NLTK library is there. And in NLTK library, there are two modules, sentence tokenizer and word tokenizer. So if you have a paragraph, it can be broken into sentences, then sentences into tokens, individual words and symbols. So these two are imported in the program. Sample.txt is my file, which is a simple text file containing some text. It is opened in read mode. So open function of Python is used to open the file in read mode. It is available as data file now. My sample1.txt, all the data is available in data file. I say data file.read and all the data of the file is loaded into the variable data. I have converted all the data into lowercase. That is the first step of data of text normalization, that whatever text you get, you convert it into one case, usually the lowercase. So lowercase data I have now, and I have closed the file because I no more need the file. All the data is there in the memory. What I have done is I have imported the NLTK library. I have opened the data file and I have loaded all the data in a variable called data. Now from here, I am coming to processing of the data. So first of all, I am getting all the sentences, list of sentences by the method sent tokenize. And I'm printing them. You see, simple for loop and all the sentences will be printed. Then I'm using similar fashion. Word tokenized method is taking the data and giving me the exact words. And those words are also printed out. So let me see if the program has run so far or not. Yes. Here is the output you see. Sentences are about yoga, yoga maintains health. These are the 4 sentences in the file. If I show you the file, see, this is sample1.txt, about yoga, blah, blah. This simple text file is over here. That same text file is processed here. And first of all, the sentences are displayed and then the individual tokens about yoga, full stop, yoga maintains health, full stop, and so on. So that's just a simple demo of tokenizing and sentence tokenizing and word tokenizing. Nothing special, just the text is broken down. The preliminary step for NLT and natural language processing has been done. So this program is simply opening the file, sent tokenize and word tokenize are breaking the data into sentences and words. Let us move on further what it is doing. This is just one simple implementation.
Sir. Hello.
Yes, sir.
Sir, when we are converting everything into lowercase, then don't you think some semantics will get lost? No? Like proper nouns will have the first letter capital. So
No,
some.
here actually in natural language processing, what happens is the AI application tries to understand that first of all, this is the text cleaning process. In text cleaning process, you need to differentiate between the tokens. So if you say capital YOGA yoga and if you say small YOGA yoga, it will take them as two different tokens. So here, what it is trying to do, it is trying to classify the documents. So it has to read one word similarly of one type. Here, no speech to text or text to speech conversion happening. It is simply processing a text file. So lowercase means a word, various representations of the same word will become similar. So yoga with capital Y and yoga with a small y, they will be turned down into lowercase. So these, now it will calculate that the word yoga has appeared in the file 2 times. Otherwise, if you do not convert it into lowercase, it will say that the word capital Y yoga has appeared 1 time and a small y yoga has appeared 1 time. So to keep that
Hmm.
arithmetic fine, we have converted everything into lowercase.
Okay, sir.
So here also just the difference is that I have taken the text over here instead of a file, and I have downloaded another module, stop words. Puncti and stop words, these two modules are going to help me. Now we are going to remove the stop words. So stop words are actually the punctuations like comma, full stop. In my text, you see the comma, full stop are there. So those can be removed also. So how will they be removed? Let us see. Here I have done the removal manually. See, punctuations, I have taken a list of punctuations and I have using for word in filtered words. Let me show you here. This is the data. Now word tokenizer is giving me all the words. All these words about yoga, yoga maintains health. All these words are into tokens. And for stop, all the possible stop words are there in a dictionary called English. English corpus is there. So by the help of stop words, I have loaded a corpus called English corpus. So it understands comma full stops. And then using that corpus, I have removed the comma and full stop manually from the data. And then I have displayed this data over here. This is the logic for removal of the comma and full stop manually. Nothing special. I'll run this and show you, then you will get the point. See, original data is this. All the words are there along with comma and full stop. And then all the full stops and commas are removed from here. In the final data, all the full stop and commas are removed. So this program is actually removing the comma and full stop. Another second step of text normalization. Now, how you will find the frequency, which word is appearing how many times, this I will show you here. First of all, I'll run the program, then I will show you the code. See this graph. And the file is this one. This is a file, the role of self-management, etc., etc. This complete text is written in this file. This file is processed by the program, and this graph is coming up, the frequency graph, where it is showing all the, just a moment, let me resize it. So you see all the words it has counted, self-management is appearing 4 times. And similarly, role word is appearing only 1 time. So many words are appearing 1 time. So here it is counting which words are appearing how many times in the text. So depending on that, it will help you to classify that this document is actually talking about what. So the highest frequency is self-management. So this document can be classified as self-management, an article on self-management or a document on self-management. It is talking about self-management. So this is one small application where you can find out the document is talking about what. So whatever the document is talking about, that word would be appearing many times. This is the logic on which we are counting on this program. So again, this is a simple demo where you can show to the students how natural language processing can be used for classification of documents. Now see how it is working. Frequency distribution, FREQDIST, FREQDIST. Frequency distribution is another module which is available in the probability library of NLTK. So this you must know to use the program. Sample2.txt I have opened for reading. All the data is loaded in data variable as usual. So this step is similar as the previous program. Stop words and comma full stop I have removed from here. And then I have created the frequency chart. I have called the function frequency dist, FREQDIST, the same name by the name of the module. It's the same name, it's a constructor. So frequency distribution method is called, and all the data which I had cleaned, comma, full stop, removed, that clean data is passed to it. It is returning all the frequencies, the list of all the words and their frequencies, and that has been plotted. So this object, frequency distribution object, is created. On this frequency distribution object, I have called the method plot. Plot method is actually creating the graph of all the tokens. So total tokens I have passed to it, and it is showing me the graph. So these programs can be shown to show the text normalization. This program is actually going to recognize the speech. So let me first of all tell you what is the flow of speech recognition. Whenever we talk about speech, the microphone comes into the picture. So whichever computer you are using, the microphone must be working over there on that computer. And the basic logic of the program is that when you run the program will capture the mic. It will capture the mic and it will start listening. Now, the moment you speak, it will take the text and it will convert that text into audio, and you can use that audio to be displayed back, for example. So for this, you need certain libraries. One of the library is speech recognition library. You can use Python's speech recognition library. You can import this in the program. Now it will recognize the speech. It will capture the mic and all those things it will do. It will interact with the device. It will capture the microphone. It will capture the voice input coming into the microphone. But rest of the processing will be done. How that voice will be converted into text. For that, you need a library called PyTTS-X3. PyTTS-X3 is the library which will help you in converting that voice input into text. So let us see how do we use it. I have imported speech recognition, and I have imported PyTTS-X3. And now speech recognition has a method called recognizer. Recognizer object is actually recognizing the microphone. I have taken it as an object R, and for text to speech to text conversion, I have called init method on PyTTS-X3 library. Init function or method is called, and it is available as the text to speech conversion engine is available to me here by the name engine. So engine is the text to speech converter, and R is recognizing the microphone, recognizing the voice. Now what I'm doing is I'm using a keyword with. With keyword in Python actually implements a loop with any object. It gets associated with an object. So what I'm doing is I'm saying with sr.microphone. See, microphone method is also available in speech recognition. So sr.microphone will give me an object called mic. This mic is actually my computer's mic. It gets associated with the mic. So sr.microphone will find out the mic device on my computer and it will attach with it. Now, whatever actions I will do further, they will be done on the mic. That's why with keyword is used over here. You see the indentation, entire thing is inside with. So अब हम mic के साथ what we will do with mic, first of all, it will adjust with the ambient or the background noise. So there is a method called adjust for ambient noise. I pass the mic method and I give a 0.2 seconds duration to adjust. That's quick enough. It will adjust with the noise so that it can recognize the voice. Then I'm calling speech recognition libraries method listen. Listen method is actually requiring the mic from where it has to listen. Time out for how long it will wait to listen, 6 seconds. Phrase time limit, how long the person can speak. A person can speak for 6 seconds. I've given the value 6. So it will wait for 6 seconds. If nothing is spoken for 6 seconds, the program will terminate. And I can speak for 6 seconds long. So here it is. It is listening to the mic now, and now I have to speak. At this moment, I have to speak, and when I am speaking, speech recognition library is calling a method called recognize Google. Google has a service, audio service, which provides the service of recognizing the audio. So all the audio conversion is converted into text over here. You see, the speech which I have spoken, that speech is converted into text by recognize Google method. Recognize Google method is actually using the Google services to convert the voice into text. So my text is converted over here. Just in case I have converted the text into lowercase, otherwise not required. But for speech recognition library, I have converted into lowercase. I have also printed the text so that I can see what I have spoken. And then this PyTTS X3 library engine is using a method called say, and I'm passing the text into it. So the text to speech engine will convert it back into audio, and I can listen the audio. So let us run this flow. Then we will revisit the program. Hello, how are you? So the program was running. So I've spoken something. Again, the library is loading. It is connecting with the Google service online. So it might take some time. But after some time, whatever I have spoken here, it will speak it back.
Sometime, but after some time, whatever I have spoken here, it will speak it back.
Did you see how it is working? So this simple program is just taking a voice input. It is using the Google service to convert the voice into text. And it is using PyTTS X3 library to convert that text back into voice so that user can hear it. Let me show you one more sample over here.
What is the item name?
Heater. Heater.
Item found. The price is 1,000. What is the item name?
So did you see here? I spoke heater. It is querying a text file and finding the heater item and telling me the price. So here actually I'm reading a file, and from the file I am taking out the query, file1.csv over here. I'll show you this file first of all. See, this file1.csv is a comma separated file. Item code 1, heater 1,000 rupees, 2 fan 2,000, 3 cooler 3,000. So it's a simple text file which I'm opening over here, and I'm using the text engine is asking me what is the item name. Run and wait method is actually making the text engine to wait. Microphone as mic, the same command is used over here. Ambient noise adjustment, it is listening to the mic and it is saying, it is recognizing my voice. I have said heater. The heater goes into the audio variable. This is converted into text. Speech text has got the word heater. That heater has to be searched into the file. File1.csv has been read for reading. I have applied the logic to read the lines of the file, and I have split the record, and I have found, I'm trying to matching the word heater. If a line is found with word heater, I'm taking out its price 1,000, the third value in the comma. And with this price 1,000, I am displaying it back. It is saying price 1,000. I run it again.
What is the item name?
Heater.
Item found. The price is 1,000. What is the item name?
I show you another quick demo.
Where do you want to go? Say quit to close.
Kolkata. Kolkata.
2 flights found. Flight F002.
So it is saying 2 flights are going to Kolkata, and it has taken out the details from the file and displaying over here.
9,000. Flight F004. Going from Delhi to Kolkata on January 30th.
This is what happens on railway stations and airports. So friends, I have shown you demo of NLP where you can clean the text, you can tokenize the text, you can convert the text into speech back to text. You can use that speech to text to query a file, open the file, finding out the word, finding out the records, converting the records again into audio and displaying that audio back. So that entire flow has been created in the program. So this is a flight number, flight originating from Delhi going to Bangalore on this date, and the flight price is this. So there are 4 records. The flights are going from Delhi to Bangalore, Mumbai to Kolkata, Goa to Lucknow, and Delhi to Kolkata. So Kolkata, there are 2 flights which are going. You see, so this is the comma separated file. This is the first value, second, third, fourth. 1, 2, 3, 4, 5 values are there in each row. On that logic, the program is working. So how it is working? Speech recognition library and PyTTS X3 library is imported. The speech recognition engine is created. Text to speech engine is created. So here, microphone is captured. These steps are simple. They are capturing the ambient noise. They are capturing the mic, the voice coming into the mic. When I said Kolkata, audio variable got the text Kolkata. Sorry, the audio was captured Kolkata, and by recognize Google method, that audio Kolkata is converted into the text Kolkata. Speech text was Kolkata. Now this Kolkata has to be found into that CSV file. All the values in the CSV file are in lowercase. So I have converted the text into lowercase Kolkata. Now here, I am opening my CSV file. Rest of this logic is actually finding the value in the file. And if the value is found, the entire record is created in a form of a string. So this is the logic to open the file, read the lines in the file, and close the file. All the lines are read into CSV data. With a for loop, I am taking out one row at a time. And for each row, I am looking where that row contains Kolkata or not. If that word Kolkata is found in that row is saved as a string. So there are 2 lines which are there in this string. By splitting those values, comma separated values, what I'm doing is I'm creating entire dialogue for the application, which will be spoken out. And this information, once the flight info, that entire dialogue is created, that is displayed by same method of text to speech engine. Nothing special. I took the voice Kolkata. Kolkata was converted into text Kolkata. Text Kolkata was searched into the file. If it is found, those lines were taken out and a string is created like a dialogue. And that dialogue is spoken by same method of TTS engine. This is the logic which is followed here. So when I said Kolkata, it reported back that 2 flights are found. You see here, flight found, 2 flights are found, and the flight details were displayed, were spoken. They were displayed as well as spoken. So this is the use of text to speech to text conversion. So we started with the Scratch interface, and then I showed you so many TTS and NLP programs in Python, in pure Python text oriented. I know this much. This is too much of to understand, but once you get the programs and run them, you will be able to get them.
I am not feeling well, so I am giving this voice input into this program. Positive, 11.1. Negative, 26.5. Neutral, 62.4. Overall sentiments seem to be negative.
So this is actually a sentiment analysis program. Whatever I have spoken, it has taken out the sentiments, analysis of sentiments is done, and it has given it back to me. So what I just showed you is the sentiment analysis program, and it is actually doing the polarity. Polarity means whether the spoken sentence is positive, or is it negative, or is it neutral. So that is done by a library called Vendor Sentiment. Vendor Sentiment library is actually doing the sentiment analysis. It has a module called Sentiment Intensity Analyzer. Sentiment Intensity Analyzer actually helps in analyzing the sentiments in the text or the speech. And depending on that, it gives the rating either positive, negative, and neutral. So this is what the program is doing. Rest I am converting into text and speech. That logic is also applied. So it was speaking actually. See, this program is actually taking a Hindi file. मैं रेस्टोरेंट सर्विस से बहुत नाराज हूँ, खाना ठंडा था और वेटर भी बदतमीज थे. So it was translated into English first. I am very upset with the restaurant service. After that, full analysis was done. Negative was 28%, neutral was 71%, overall was 70%. So overall prevailing sentiment was negative. Similarly here, sandwich na to bahut garam hai na hai bahut thanda. This is translated into English and then sentiment analysis is done. Sentence is found to be neutral. And this is taze samoso ki mehak lajawab hai. The aroma of fresh samosas is amazing, translated. Sentiment analysis is done and it is positive. So this program is actually doing sentiment analysis and the data is coming from a text file which contains Hindi text. UTF-8 is Unicode format, which is used to understand Hindi language. Google Translator is actually doing the translation of the language to English. Google Translator library is being used here for translation. And once the Google has translated the text, the English text is stored in ENG text variable. Polarity scores. As I told you, Sentiment Intensity Analyzer. This library has a method called polarity scores. It will do the sentiment analysis on English text and will calculate how much is happiness, how much is positive, how much is neutral, and how much is negative. And that entire data is loaded into SentDict variable. It is actually a dictionary of values. And then that dictionary is displayed. You see, entire dictionary is being displayed over here. Set negative, positive, and neutral data is displayed over here. And in SentDict, there is third key called compound. Compound key actually shows the prevailing emotion, which is the most dominant emotion. That is also displayed. So this is the simple plain outline of the logic, which I have explained you. So in this very short session, I tried to cover up so many things. The idea was to show you the things which are possible in classroom. And we think that artificial intelligence is all theoretical. No, we can create small samples of these kind of demos and we can show it to the students in classroom. The complicated programs can be broken down and they can be taken up as a project, as a working project, or for additional learning of the students. So first of all, you have to ensure that the basic Python should be very clear to the students. They should be very much familiar with while loop, for loop, the with keyword, and how to import the libraries. Then you have to give them a primer on why different libraries are there, what all sorts of libraries are available. And then in small chunks, you can show these programs to them. So at this moment, friends, we have come to the end of the session. So today, actually, I have given you little insight on some practical part of AI, which you can use with the help of Python and machine learning platforms. And around your teaching and learning process in classroom, you have to see where you can incorporate them, or you can put them as an additional learning activity in lab. So thank you once again, all of you. Have a nice weekend. You have taken out time from this evening. That's really encouraging. Thanks, all of you.